Okay, so this is part 2 of the introduction for the remote sensing module. The motivation behind working on this remote camera trigger is for a platform where we want to do remote sensing. Imagine this scenario, for example. You've just had a natural disaster. Could have been like a tsunami, like the one in Japan in the past few years. Could have been after a hurricane, maybe after a flood, like the ones that occurred in Colorado just a few weeks ago. But regardless of what kind of disaster it is, a lot of infrastructure is down. You want to assess the damage. You want to be able to help the disaster relief efforts. And you also want to have ways to look for survivors. And all of this can be helped if you are able to image the area of the disaster. But because a lot of damage was done, it might be hard to get a system in place really quickly in order to look at the area that was affected. So one solution to this problem is to employ a device called a BalloonSat. What a BalloonSat is, and that's shown on the photos that you see here, is it's a small structure that is a satellite in quotes because it doesn't actually go into orbit, but a small payload that is attached to a weather balloon. And it's something that all you need to do is blow up the balloon, attach your BalloonSat to it, and let it go, and it will float up, and that will be a great platform for allowing aerial imaging of an area. There's not a lot of equipment required. The BalloonSats themselves can be stored and made ready in time of a disaster very quickly. More details about a BalloonSat. So if you put something on one of these weather balloons, it can reach up to 100,000 feet in altitude. That's high enough to start seeing the curvature of the Earth. You can carry payloads like cameras, transceivers, other things on your BalloonSat, and as a result you can send photos or even live video feeds back down to the ground, which would be a great help in the scenario that I mentioned before, like for a disaster. The photo on the bottom left of this slide is some students from the University of Hawaii just setting up a ground station to track one of these BalloonSats and communicate with the BalloonSat. So it's just in the back of someone's truck. So you can see it's something that's easy to deploy and fast to set up. So it's good for a disaster response. Inside the BalloonSat you can have different components, and that's shown in the this diagram on the right side of this slide. So there's different subsystems. Like for example the camera, which would be key of course for this mission of remote sensing and imaging. A transceiver, which would send and receive radio frequency transmissions. Maybe you want a GPS on board so that you know where your BalloonSat is and where these photos are that you're taking. A central processing unit to control all of that. Power supply to supply power to all of these systems. You need memory on board for your CPU. Also memory to store the data. It could be, in this case, it would be the pictures from the camera. That's the data that you want to store. And then another thing that is unique to something like a BalloonSat, where you have a more harsh operating environment. As you start going higher and higher up, the temperature drops really quickly. So you would have something like a thermal management system, because some of the electronics may or may not be able to operate at these lower temperatures. So you may need to have some kind of system that will maintain temperature within the BalloonSat so that all your systems will operate. For example, the battery. a lot of batteries don't have a very large temperature range. So thermal management might be necessary to make sure that your battery is still going to supply power. Here's an example video of a BalloonSat that was launched um, off the island of Oahu. If you're familiar with that, this is over the Hawaii Kai area. So all of this stuff is the Koko Marina area that you're seeing. So this is video that's being transmitted from that BalloonSat back down to the ground. So you can see how it would be very good for imaging in case of a disaster. Here's some other photos instead of videos from a BalloonSat. This is near the highest operating altitude of a BalloonSat, around 100,000 feet, and as you can see the curvature of the Earth, and it's very good for wide area imaging.